Assalamualaikum warahmatullahi wabarakatuh. So my name is Syarafana Binti Suhaimi. My metric number is AN190096. For my title final year project is Effect of pH on Textile Wastewater Treatment in Membrane Photocatalytic Reactor MPR with presence of ZnO-MO nanofluid. So first of all, textile wastewater are high in pH, SS, color, COD and salt. The MPR system has some major advantage including low cost and eco-friendly. Zinc oxide that act as photocatalyst in the photocatalysis process can cause agglomeration, and to reduce the precipitation, they have to add PVP. pH play a significant role in the photocatalytic activity. Hence, there is no previous study investigate the effect of different initial pH and the reaction between ZnO with presence of MO in textile wastewater. Therefore, this study will discuss about the effect of initial pH, pH 4, 7.5, 11 on textile wastewater via MPR in presence of ZnO-MO. Several parameters tests were run as pH, DO, turbidity, color intensity and COD with mechanism of membrane falling based on blocking filtration law. As for the introduction, textile industry utilized a huge amount of water consumption on some of their process, including dyeing and printing process. MPR is the combination of membrane technology, membrane separation, and photocatalytic degradation process. ZnO-MO are used to act as photocatalysts for the photocatalytic degradation process in this project. The different pH value of wastewater are utilized in order to determine the best pH value for the photocatalysis process. The objective of this project are to determine the functional groups of the prepared ZnO-MO, to investigate the effect of different initial pH value of textile wastewater treatment via MPR in presence of ZnO-MO, and to elucidate the mechanism of membrane falling using model fitting according to the theory of blocking filtration laws. The application of membrane photocatalytic reactor for textile wastewater treatment has become a popular case among the researchers of this wastewater field. MPR is the most efficient hybrid system for wastewater treatment. This hybrid processes has overcome number of the difficulties which are related with conventional methods and promote process intensification. It is due to their spacious surface area that can give a better contact between pollutants and photocatalysts. It has been reported that it is possible to achieve a higher efficiency on treating the wastewater compared to the others. Unfortunately, falling is an important problem for the system because of their cross-flow velocity and sludge retention time. So first of all, as for the methodology, ZnO-MO nanofluid was synthesized by precipitation method but in liquid form. Then, the functional group of ZnO-MO was determined by using FTIR. After that, MPR system were used to conduct this study. The membrane sample was be wiped out by using the circulate RO water under 6 bar of pressure for 30 minutes. Graph of normalized flux against time was plotted to determine the R2. After the graph has been plotted, if the R2 more than 0.9, the textile wastewater then was poured into the reactor at a volume of 500 ml with 2.25 ml of 9,1-DES solution. Then, for analyse of water quality, it was measured and analysed based on their pH, DO, turbidity, color intensity and COD. Then, it was compared with discharge standard by DOE, either it complies or not. From the linearized equation for each type of mechanism, the equation was simplified into y equal kx plus 1, whereas y is verified according to the falling mechanism. that the Foley mechanism of membrane was evaluated according to the theory of block filtration law. The block filtration law base was employed to identify the mechanism of membrane falling during membrane filtration of textile wastewater, which are complete blocking, standard blocking, intermediate blocking, and cake formation. Then the data was collected and recorded on the table. So, as for the result, Figure 1 shows the FTIR spectra of commercial ZnO. Based on the figure above, there are some characteristic adsorption perks appear in the range of 6,000 to 600 cm -1. The perks that appear at 3340 represent the OH stretching due to the broad adsorption band in the range between 3650 and 3250. So basically, these bands are proving the existence of hydrate, H2O, hydroxyl, OH, ammonia or amino in the solution. Hence, it's proof that ZnO sample has observed the existent water from the surrounding. Next, the adsorption band at 1635 is due to the stretching of CO bond. The intensive adsorption perks at 663 correspond the standard perks of ZnO because of the stretching frequency of ZnO bonds that confirm the existence of metal oxide. Figure 2 shows the FTIR spectra of ZnO-MO nanofluid 91D as solution. So basically, the composite field wavelength number 3355 was attributed the OH stretching of flavonoic compound or flavonoid. This is because quinine leaf extract show the presence of phenol, phenolide and coumarin. The adsorption band at 2353 shows the existence of CC bond. The adsorption bond of CO bond that appear at 1635 are because of the acetate group improper decomposition. As for the band at 1134 until 663 represent MO and ZnO composite is indicative of the ZnO bond, which verify the presence of ZnO in the MO matrix. For 578 to 59 show the interaction between ZnO and MO. Next, Figure 3 shows the normalized flux analysis of ZnO-MO under the three different pH value, which are 4, 7.5 and 11, that represent acidic, neutral and alkaline wastewater. The objective is to investigate the effect of pH on textile wastewater treatment via membrane photocatalytic reactor in presence of ZnO-MO. Based on Figure 3, it can be seen that pH 4 has the higher normalized flux compared to pH 7.5 and pH 11. The pXC value of ZnO can be found in pH 6 until 8, which making the pH is lower than the pH pXC. Basically, at pH lower than pH pXC, it donating more proton and make the surface of material is positively charged. Hence, it will attract the more negative charge and kill off several organic matter in the wastewater treatment by forming bonds with excess hydrogen ion, slowing down their growth and biological activity. Most organic matter are best suited to a neutral or slightly basic environment. Therefore, the optimum pH for this case study is pH 4. Next, for analysis of permit, based on table 1, it shows the optimum pH for this test is pH 4 because it has the lowest pH reading compared to pH 11 and pH 7.5. This is because reduction happened by reduce the pH of permit after photocatalysis process, which is 6.32 to 6.01 after membrane process. In addition, it shows also reading of pH after membrane process for pH 4 past the acceptable range for discharge standard by DOE for photocatalysis and membrane process. Therefore, pH 7.5 has the highest pH for both process, which are 8.19 after photocatalysis process and slowly increase to 12.39 after membrane process compared to the other two initial pH. It is due to several technical problems happened during the test was start, including foreign contaminants in the container or maintenance of MPR. Further experiment should adjust the reading for pH 7.5 after membrane process. Next, for DO reading for each of the initial pH. Dissolved oxygen, DO, are referred to the presence of non-compound oxygen in a solution. From table 3, it shows that the lowest DO reading is pH 11 for photocatalysis process and membrane process. This is because it reduced the DO reading from 9.55 after photocatalysis process to 9.33 after membrane process. The DO reading of pH after membrane process also above 5 mg per L, so aquatic life is not put under pressure. Meanwhile, the highest DO reading is pH 7.5. This is because the DO reading after photocatalysis process is 10.27 and slowly increased to 11.21 after membrane process. As for the turbidity, pH 7.5 has the lowest turbidity reading compared to the other two initial pH. Some reduction happened because the turbidity reading after photocatalysis process is 31.5 and go down to 1.02 after membrane process. It is because pH 7.5 is neutral and optimum, which make the water more clean and clear. Hence, the low turbidity indicate high clarity. Meanwhile, pH 11 shows more turbid in photocatalysis and membrane process compared to the other two initial pH. This is because of the high pH value of a solution can reduce the degradation of organic molecule and make the hydroxyl ion compete with the organic molecule for the adsorption on the surface of the photocatalyst. Moreover, permit at pH 11 more cloudiness or haziness and indicate low water clarity than pH 4 and pH 7.5. Next is for the color intensity. The lowest color intensity reading is pH 4. This is because it reduced from 8 to 8 ADMI after photocatalysis process to 83 after membrane process. Hence, when the color reading decrease, the intensity of the permit increase. The color intensity reading after membrane process for pH 4 also passed the acceptable range for discharge standard by DOE. Meanwhile, the highest color intensity reading is pH 11 after photocatalysis process, which means more amount of dye or suspended material present in the permit. When the pH value is higher, more negative charge will present, which making it has the high color intensity value. As for after membrane process, it shows the pH 7.5 has the highest reading of color intensity and the value is not past the discharge standard of DOE. Further experiment should be required until the value past the acceptable range. From all of the color intensity reading, some reduction did occur for each of the initial pH value. For COD, pH 7.5 has the lowest COD reading after photocatalysis process, but pH 11 has the lowest COD reading after membrane process. Therefore, several amount of contamination that enter the water has been reduced. pH 4 has the highest COD reading after photocatalysis process, and pH 7.5 has the highest COD reading after membrane process. It has been mentioned experiment that at lower pH value, functional group will pronate and rise up the positive charge of the photocatalyst source. This caused decreasing in degradation of organic molecule. Also, the discharge standard by DOE is 80 and it shows that all of the COD reading not past it, but there are some reduction compare photocatalyst COD reading and membrane COD reading. Hence, further experiment should be done until the COD pass the acceptable range for discharge standard by DOE. Table 2 shows the mechanism of membrane falling for all of the pH value, which is pH 4, pH 7.5 and pH 11. It can be seen that all of the membrane mechanism fit well in all of the condition, but the fitting result of complete blocking was poor because it has R2 less than 0.1. Hence, it assumed that complete blocking was inegligent for all of the condition. It might have some solute size not allow every solute to precipitate in the blocking the entrance of the membrane pores completely. The most significant blocking occur for pH 4 is intermediate blocking mechanism. This is because it has highest value of R square. It can be assumed that several particles will directly block some of the membrane pore, which affect the K value due to the consistent decline of the permeate flux. Besides, it shows that the K value of the intermediate blocking mechanism is the second highest compared to the other three blocking mechanisms. As for pH 7.5, the result shows that the standard blocking mechanism is the most mechanism blocking occur. The assumption that can be considered is the membrane pore volume decreases proportionally to the permeate value due to the deposition of particles on the pore walls. It is because the particle size is considered as small compared to the pore size. Also, the gradually decline of the permeate flux for pH 7.5 is made due to the low rate constants and the construction of membrane pores due to their small particle deposit onto the pore walls, which prove from the result that the K value of the standard blocking mechanism on pH 7.5 is the second lowest compared to the other three blocking mechanisms. Based on table 2 also shows that intermediate blocking is the most blocking mechanism occur in pH 11. Those fallen has reaching the membrane but also attached on other and already deposit. It also has the second highest K value compared to the other three blocking mechanism. So as for the conclusion, the functional group of the ZnO-MO has been analysed using FTIR with the presence of OH group, CH group, CC group. Next, the pH 4 of textile wastewater is an optimum pH for this study due to their better performance in terms of pH, DO, turbidity, color intensity and COD by comparing with other initial pH value. Next, the mechanism membrane blocking occur in pH 4 is intermediate blocking with the R square 0.96472 and K 0.008559. It was identified by using MATLAB software according to the theory of blocking filtration law. The recommendation is further study should be carried by using another source of photocatalysis in textile wastewater treatment so it can be easily be commercial to the real industry, such as ZnO, Fe2O3. And that's all about my final year project. That's all from me. Thank you.